One of the more frustrating parts about SwiftUI, as good as it is understanding how views are laid out and what views get priority over another one. Hi, my name is Stuart Lynch, and in this video we're going to take a look at the SwiftUI layout system, and in particular, look at how the ignoresSafe area modifier applies to different views, and try to get a handle on laying out text views to make sure that your text is displayed the way you want it. We'll be looking at layoutPriority, the fixedSize modifier, lineLimit modifier, and also how dynamic type might affect your views. Before I get started, let me request that if you enjoy this video, please leave a comment below and give it a thumbs up, and subscribe to my channel. Make sure you ring the bell to be notified of new videos. And if you want to support my work, you can buy me a coffee. I'll leave a link in the notes below. If this is something you want to learn, then keep watching. I have a starter project for this tutorial, and I recommend that you download it and try out these examples along with me. Feel free to experiment because that is really the only way that you can get a handle on how SwiftUI views are laid out. I'll leave a link in the notes below. There are two views that we'll be working with. One for the introduction and the ignoresSafe area section, and then one for the layout priorities and laying out text views. I've also created a custom style called Random Border Style, and I'll show you the purpose of that shortly. As I want to be able to do some testing on the simulator, I've also created a tab view called the Main View that will allow us to switch between views easily when we get to that. Consider this simple SwiftUI view, and it's a simple text view. How does SwiftUI decide how to lay this view out, and how much space will it take up? By default, SwiftUI lets each view decide its own size based on the container that it's rendered in, and will then center it within its parent. SwiftUI views basically conform to one of two different expanding behaviors. The first one is hugging behavior, that is what the text view does, and by this I mean that the content will determine its own size. The view will take up only as much space as is required to display the content, and then it's offered to the parent view and centered within that parent. So, what's the parent of this text view? Well, first of all, it's not clear how much space the text view is taking up, unless I select the view and I see a faint border is applied around it, so that we can see how much space the view takes up. If I click elsewhere within the code, I lose that outline. I like to see that outline all the time. So I've created a custom style that you can find in the Random Border Style. If I apply that style to this text view with no parameters, it places a 2-pixel wide border of some random color around the view, so that you can see the view boundaries without having to tap on it. So let's do that by adding a random border here, and let's also set the font to a large title. We see that the border grows to accommodate the space needed for our now larger text. But how big will it grow? And what happens if there's no more space left? And what is the space available? And is it really centered on the screen? It looks like it. Let's run on the simulator, because it's going to be easier for me to see in this next step. And I'm going to encourage you to set the window so that our device is point accurate. Now I'm going to launch a tool that I have that's called PixelSnap, and it is part of the SetApp collection, and I'll leave a link in the notes below. You can also purchase it as a one-time purchase, but SetApp is a fantastic collection, so you have access to it plus a wide range of other very useful apps for a small monthly or annual subscription fee. I am not sponsored by SetApp, it's just what I think. Anyway, let me bring up this view and measure. If I measure from the top of our device to the top of our text view, and then again from the bottom to the bottom of the text view, if this were centered, these measurements would be the same. However, when I do that, it's 408 from the top, whereas only 394 from the bottom. Well, why is that? Now, as I said initially, by default, a view decides its own size based on the container that it is rendered in. And this then is the body. So is the body somehow restricted? Well, we can find that out by taking advantage of a Z-stack and a color view. Now, a color view is the second type of view category in that it will expand to take up all of the space that is available to it. So if we create a Z-stack and paste a color view as the first element in that Z-stack, it will expand to the entire space made available to it, which is its parent. And then as the second item, we'll see our text view is placed within that same parent content. So first, embed the text view in a Z-stack. And then in the first view, we can create a color view. And instead of displaying a border around it, let me use a solid color like green. Notice that it doesn't go and cover the full screen. Now let's be clear. Our text view is no longer a child of the body, it is a child of the Z stack. And the Z stack is the child of the body. So if I run this in the simulator and measure now, I see that the text view is 361 pixels from the top and from the bottom of our green color rectangle. Now this is not the effect I want. I'd like our color view to extend beyond our safe areas. So what I can do is add ignoresSafe area modifier to it. And it'll tell our app that we want the green background to extend beyond all safe areas and expand to whatever width it can make. Now if we run this app again in the simulator and measure the location of our text view, we see that the location has not changed with respect to the full screen. It is still 408 from the top and 394 from the bottom. Now when we think about this, this makes sense. The ignoresSafe area is only being applied to the color, not the Z-stack. Well, we can prove this by adding a random border to the Z-stack to see what size it really is. It's still within the safe areas of our text view's parent, and that Z-stack is what is restrained. Only the color has extended beyond it. The solution is to apply the ignoresSafe area to the Z-stack and not the color. That way, all of its children will adhere to the boundaries. So let's remove the random border and then also the ignoresSafe area from the color and apply it instead to the entire Z-stack. It looks like nothing has changed, but when I run this on the simulator, I can see that we are exactly 400 from the top and from the bottom. This is a cautionary tale, however. Let me embed the Z-stack in a navigation view, and I'll give it a title of ignoresSafe area. I'm going to run this on the simulator now and check with our measuring stick. You'll see that we are still centered. You would think that the navigation view, being the parent now, would also have to have ignoresSafe area applied, but it doesn't. This is good to know. If your parent content is inside a navigation view, ignoring safe areas, then your content will be centered within the parent view, which is in my Z-stack. However, this may not be what you really want. For example, if we want our text view to be pushed up to the top of the screen, but below the navigation view, let's embed it in a V-stack and add a spacer. This is definitely not what we want. The ignoresSafe area is indeed being applied to the Z-stack and everything in it. So our V-stack is also ignoring the safe areas, so the spacer is pushing up our text view right to the top. Not good. I wanted to present this as a cautionary tale because you must be very careful where you apply the ignoresSafe area, and it all depends on what you want to accomplish. Likely in this case, you'll want your text view at the top below the navigation bar. So we need to remove the ignoresSafe area from the Z-stack and place it just on the color view. So it's just going back to the beginning again and applying ignoresSafe area to the color green, but realizing that our text is not exactly centered within the entire device. In fact, it's not even centered below the area of the navigation bar because there still is that safe area at the bottom. Well, let's just run this once on a device, and it's always good to test different orientations. If I rotate the screen to landscape mode, the navigation bar is now showing inline, and it looks like the color is behind it. There is nothing that we can do to ignore safe areas here that will resolve this. What you're going to have to do is to stylize the navigation bar if that's what you want when it's in line. And that's beyond the scope of this video, but I do have a video on navigation bar styling, and I'll leave a link to that in the notes below. The other thing that will be ignored is a tab bar, and this too can be stylized in the same way. If you open the main view right now and view it in preview, you'll see that I have added a tab view, and the first view is our introduction. And you can see clearly here that the green color is behind the tab view and not in front. You can go to the SwiftUI layout.swift file now and change the initial view to main view so that in the next exercise, if we want to run in the simulator, you'll be able to tab to the second view where we will be able to view the text view layouts and layout priorities. Now, before I move on, I found that this article by Samuel DeFago on understanding SwiftUI layout behaviors to be an invaluable resource, particularly the section at the end on view taxonomy, where you can view which view types have hugging or expanding characteristics and in what directions. Another great resource is John Sundell's 3-part series on a guide to SwiftUI layout system. I'll leave a link to both in the notes below. In this section, we're going to talk about layout priorities and try to get a handle on why two views of the same type might respond differently in a layout and how you can control to get the look that you want. A great resource for this is Swift by Majid's blog on layout priorities in SwiftUI. I'll leave a link to that in the notes below. If you go to the Layout Priorities view in the Starter project, it's a simple view with a single text view inside. Let's do what we did in the last video and add a random border and set the font to Large Title. Next, I want to embed this in an H stack and duplicate the text view. I want to make sure that I keep the font modifier outside of the H stack so that it applies to both of the text views. Now the H stack itself is a view that will expand to the size of both objects within it. And we can see this by adding a border to it. We see that it exactly contains the two child views and that the border overlaps. If I want to move the border outside, we can add another additional argument to the border modifier with outside being true instead of the default false that places the border outside. And while we're at it, just for completeness sake, there are two other arguments that you could add to this style. One is to add a fixed color instead of a random one. So let me choose a color of red. And the default border is 2 pixels. I'm going to add one of 4. This makes it pretty clear. But let's just return to the simple outside being true. You may have to refresh your view to make sure that you can see that the outside view isn't one of the same colors as the inside view, or if it's not clear. Now the H stack has expanded horizontally to fit both text views, along with the spacer, which I believe is just 8 by default. Now what will happen if I increase the spacer or add more text to one of the views? Let's keep the text the same for now, but increase the spacing to 49. The text expands right to the edge of my view. If we go one higher to 50, the H stack runs out of horizontal space and the system has to make a decision. How do I accommodate? Well, the first view wraps the text while the second one remains true to the same way that it was before. This is called layout priority. If there are no other modifiers affecting the view, something called layout priority takes over. And by default, every view has the same layout priority, which is 0. And if all layouts within the container have the same layout priority, one has to adjust. And in the case of this one here, the first one has to wrap. Well, we can change that priority by specifically setting that priority of one of the views over another with a higher priority number. So let's just set the first priority to a priority of 1. Now the reverse happens. The first one doesn't wrap, but the second one does. It still has to fit within the space made available to it. If we set the second view to a layout priority of 1 or higher, then it would take precedence, just as if they were both 0 or if one was higher than the other. Let's remove both of these for now, and there is another way to specify that you don't want the text to wrap, and that is to specify a fixed size where the horizontal is true and the vertical is false. Now this is different from setting a specific frame size. This just means that the view will continue to expand to take up as much space as needed. The problem with this might be, however, that this really takes precedence and will always expand even to extend beyond the extent of its boundary, which is our H-stack, and it can also push the views out of sight. So let's add to this text, hello world, and place and we go here. And we see what happens. If we run this in the simulator, and make sure that we go to this tab, we can see the same thing that we had in our preview. However, if we rotate the landscape mode, there's more space for that H-stack, so it can accommodate that larger amount of text. Let's switch back to a layout priority of 1. It realizes that there is only so much space, so this forces our view to wrap, but the second view is not really satisfactory now. What you might try instead is to set the fixed size on that first view to horizontal false, but vertical true. Let's make both of the texts the same for both views. This is looking pretty good. But what happens if one of those views is really long? So let's duplicate and double up the text for the first view. Now we see that our first text view is going outside it and extending beyond the bounds of our H-stack. We really want to limit it to a maximum number of lines, which in my case looks like 5. And we can do this by applying a line limit to our text view before applying the fixed size. This will truncate the text and stop rendering after 5 lines. You really do have to apply a number of these different techniques to get the design that you want. And you also need to know what text you're going to be displaying and whether or not the user has engaged in some adaptive technology that could greatly increase the size of your text, especially if you're using dynamic fonts. And I am here. So let me run this in the simulator. And now I'm going to go to the Settings app and go to the Accessibility tab. From here, I'll choose Display and Text Size, and I'm going to turn Large Accessibility Sizes on and scale up the font. Let me return to the app now, and we see that the views are still contained within our H-stack, yet less content is being displayed. As one last test then, let's quit and double up the size of the text in our second view. It has no priority or fixed size. What will happen? Will it expand beyond the H-stack's vertical boundaries? Well, let's see. Running one more time on the simulator, I see that it does not. We're good. In fact, you'd find that if you doubled this text up even more, let's try this. we'll see it grows, but still doesn't exceed the boundaries of the content height. It too gets truncated. So having your text display correctly can be a challenge, particularly if you have a lot of text with container views of H-stacks and V-stacks. Hopefully this section has given you some tools to work with to make sure that you are contained within your display content no matter what the size or amount of text there is. You may have to make some design decisions and set your own priorities as to what content is the most important.